Okay, so this video is going to be on graphing linear inequalities, and when we graph linear inequalities, more often than not, you should be in the form of y equals mx plus b. This is what we call slope-intercept form. Now, it doesn't mean that your teacher is always going to give you an equation is that in that form, and this video will also cover an equation that may be presented to you in ax plus by equals c format. And we'll talk about how we switch this into this. Okay, I'll just go through the steps. But if you have not seen the video or maybe watched my video on converting from standard to slope-intercept, you may want to go ahead and watch that video before this, or you can try to learn it from this video by me just doing the steps. So anyhow, what we're going to do is we're going to talk about the notation. So we are going to be basing our equations off of this y equals mx plus b. Now we're inequalities, so we're going to be replacing the equality with either a greater than, a less than, a greater than or equal to, or a less than or equal to. Now all of these symbols, okay, now have something different and unique with them. And what I mean by that is that now that I have these symbols, okay, in inequalities, every inequality has some sort of shading and marker associated with it. Okay, so when you were talking about linear, nonlinear, so you're just talking about one variable, you were talking about shading a number line right or left, but you're also talking about an indicator. So now we are going to take from that and we are going to move forward. If you don't understand what I just said, then you can just follow along in a second. So what I mean by what I was just saying to you is that this first thing where it says y is greater than, okay, has something associated with it. And what it has associated with it is it's going to let me know whether I'm shading up or down, and will also let me know how I mark my indicator line, my barrier line, however you want to think of that, or my actual line that I am drawing. So a couple of things. If it is greater than, we are talking about the y coordinate. That's an important distinction to make versus x and y, because we are going to be graphing these things on a coordinate plane. So on a coordinate plane, we have two directions. We have up, down, we have left, right. But when we solve for these, when we put them into that y equals mx plus b, we are going to be solving for y. So we have a y that is greater than y or less than. And therefore, we are now thinking about shading up or shading down from a line. So if it says y is greater than, that is an indicator that greater, okay, y coordinates get greater as they move up the axis. So what this indicates to me before I do anything is that I'm going to be shading up. Now, the other thing that it does is that because it is not equal to, it also lets me know that I should be using which one of these. So will I be using a dashed indicating line with open circles, or I will be using a solid line with closed circles? Well, at one point when you were graphing inequalities, your teacher should have, or you should have learned that a non-equal to will be the open circle. So by having a non-equal to, I also know at this current moment that I will be using the open circles, okay, with a dashed line, and that's how I'll indicate my line. Moving on to the next one. So this less than, okay, less than will indicate to me that I should be shading downward, okay? So I should be shading down from the line. Also, though, what you will note is because it's not equal to, all right, I will also be using these open circles with the dashed line, okay? So just so you have there, all right? Now, again, okay, we look at this bottom one, and again, notice I have a greater than, except this time it's now equal to. Well, greater thans all represent shading up. So what you should begin to notice is that there is a definite link between these two. And the link between these two is the fact that they're shading up, okay? So the link between, again, the greater thans, okay, is that they shade up. So now what I'm going to take a look at is what does the line look like? Well, now because it's an equal to, all right, you can think of that equal to bar as kind of giving you a hint that you should have a solid line. So I'm drawing a solid line with solid points, all right? The one then below it is a less than. So if you notice before when we had less than, okay, same thing. The shading is going to be down from that line. So I know that it's going to be a shading down from that line, but because it's equal to, I also know that it's going to be a solid line. So the notation's important because you have to know the notation is associated with inequalities. Once you have this notation down, all right, and there are similarities. Notice not equal to is always open circles with dash. Greater thans are always up, but equal to's are always solid. So you can see that there's similarities linking things. But anyhow, let's go ahead and look at some examples of how you would do these problems. So the first one I have here, it says graph y, all right, is greater than or equal to 3/4 x minus 5. So off on some side notes here, okay? So side notes, all right, are this. There's a couple things I know. So again, from that previous screen, it says y is greater than or equal to. So I know right now I'm going to be shading up, and I also know, because it's equal to, that I'm going to have solid points. So these are some of the indicators that I have that I need to be thinking about off the get-go over here, all right, that I'm shading up because it says y is greater than. I know that it's solid with circles because it's equivalent to. So those two things are the first thing that I'm going to note after it says y by itself. And we'll talk about what I mean by that in a couple videos from now. Now, the next thing I have to do is I have to generate some points. So there are two ways to generate points, okay? To generate points, you can either use the table, okay, to get points from that equation, or you can use your rise over run and your y-intercept. So m equals and b equals are the things that you'll be using, and I will show both in this particular video, but I'm a fan of the table, so we'll move from there. So the table. So the way you get the table is you should always know your y-intercept, okay, as being the second part here. I circle it up because why? Because that gives me my first point. The 0, okay, so put a circle around there. I get my first point, which is 0, -5. To get my second point, all right, is a pretty easy process. The second point is done by taking the denominator, that is your next x-coordinate. So my next x-coordinate is 4. So I write 4. Now the answer for y, we can do a little cheat sheet here, that if you just simply take this numerator and stick it with this y-intercept value, you will get the outcome. So 3 and -5 make -2. So I'm going to record that over here, -2. Now what I have are 2 points, and 2 points I can easily plot. So I plot those points. So when I plot the points, I'm going to use my stuff up here. So my points are solid, so I'm going to make solid points, and then I will connect them with a solid line. After that, I will then shade above the line. So here we go. Point 0, -5. So 0, -5 is right here. And then the point 4, -2. So 4, -2 is this point right here. Then I can go ahead, connect them with a solid line. And now the last step is the shade up. So I should shade up from the line. Okay, so then I go up here and I shade everything above this line, and then I'm done. There is my inequality, okay? So it's a little bit more work than just graphing a line. We do have to shade some more, but then I'm done, okay? So on to the next one. So now this one says, graph the line y is less than or equal to 1/3 x plus 4. So again, I'm going to go use my side notes. So I'm going to go over here. I'm going to go my side work. All right. My side work, again, if we go back to the original notation, because it says y is less than, I know that I'm shading down. And it's not equal to, so I know that I'm using a dashed line when I get my points. And I'm going to connect my points with open, and I'm going to use open circles, okay, to represent my points. So I didn't in the last segment do what I said with the rise over run, so I'll apologize. I'll do that on this one. But anyway, I'm a fan of the table, so I'm going to use the table, so you'll see that now. So again, the way you get your point from the table is easy. This first coordinate is always my y-coordinate. You should know your y-intercept is always across from 0. And if you need a little way to help remember that, I circle that value up, so I have the coordinate 0, +4. The next step from there is to get another point. So the way you can use a little cheat sheet if you want here is that my very next x-coordinate is always the denominator. So I use 3. So I'm going to write the number 3. So 3. All right. Now, the way I get my outcome for 3 is if you want to plug it into the equation, go ahead, but there's a little cheat sheet you can do. And the little way you can do a little hack here to get another point is to simply take whatever the numerator is and add it to what your y-intercept was. So 1 plus 4 is 5. So I go ahead and record that answer as 5. And now I have 2 points. So I have the coordinate pair 0, 4, 3, 5. Now when I go ahead and graph those points, remember I'm going to use open circles with a dashed line. So that's the first thing I'm going to do. So the point 0, 4, so 0, 4 is up here on the y-axis. The next point is 3, 5, so I go over 3 and then up 5. So 3, 5 is the point right here. I'm going to go ahead. Ooh, I made a mistake. Does everyone see the mistake I made so far? See, easy to make mistakes here, right? So I want to use open circles, so I do apologize. So in this case, open circle, so I go over to 5, 3, open circles. Sorry, made a mistake. So then from here, I go ahead and I start dashing my line to connect the points. So if you notice, there's that. I only need to show 2 open circles. I don't need to open the whole way along the way. If you want to show extra ones, you can, but that's all I need. I have my dashed line. The next thing, the very last thing that I do, okay, is remember that I shade down. So I know that I'm going down from this line. So what I do is I put little arrows that go down from the line. So there we go. And then I'm going to go ahead and shade everywhere below this line that exists on this graph, and then I'm done. Okay. So, like I said, I would share with you for this one. So the other thing we can do is we can graph stuff with m equals and b. So we can use our slope, which is rise over run, and then our b. So I'll go ahead and show that all to you now. All right, so let me go ahead and erase all this stuff that's on here, just in case your teacher does it a different way, and all teachers do things differently, so they're not all the same. All right. So what I now have, okay, is that if I want to do this with m and b, all right, what you need to do, all right, for your side work is that you label b, all right, as 4, and that comes from your equation 4, but you need to know that that's the coordinate pair 0, 4. So regardless, notice you start the same up here. So when I mark that on the graph, there it is, open circle. The next thing that people may like to do is the rise over run, which is 3. So that means from the point 0, 4, I move up 1 coordinate and over 3. So I'll try to show that as best as I can here, but I go up 1 coordinate, so up 1 coordinate, then I go over 1, 2, 3, and there you notice I'm back at that point. So that's using rise over run, and then I mark that point, and then again I use the dashed line. Okay, so I'm doing this in red, but then you still have to come back to this side work. This side work piece is a little bit is the same. Okay, so dashed line, and we shade down from there. So we shade everywhere below the line. All right. So on to another example. Okay, so this example is a little bit tougher. And the reason this example is a little bit tougher is simply because it doesn't start off with y greater than or less than equal to. So my side work now is actually going to be, all right, making it so that it says that. So what this means is that I got to convert this 3x plus 4y greater than 20 into y is greater than, or maybe y is less than something. So what I'm going to utilize here is properties of equality. And I'm going to move everything around until I get it where it's just y by itself. So the first thing I'm going to do is I'm going to get this 3x out of Dodge. And the way I get 3x out of Dodge is that I turn it into a 0. And the way I turn it into a 0 is I just do minus 3x. And what I got is 0. But I'm using properties equality, so what I do to one side, I do to the other. So I write minus 3x. So then from here, I can record my next level, which is going to be 4y is greater than. Now I'm going to write the negative 3x first. So negative 3x. Positive 20. So my last step from here is I've still got to get rid of this 4 because it's got to be 1y, not 4 y's. I want it to be 1y. So the easiest way to make anything 1 automatically is to use the process of division. If I divide anything by itself, it will automatically make 1. So I'm going to divide by 4. Now, notice that there are 2 terms over here. Well, much like multiplication is distributive, okay, you can distribute division likewise. So if I have two things over here, I'm going to divide two things. Okay, so now what I'm going to do is I'm just going to simplify this final answer. So I now have y is greater than negative 3/4 x plus 5. So from here, I can now go back to the thing I did before. And the thing I did before is I can now decide whether I shade up and whether it's a solid or it's a dashed. So the first thing I notice is it says y is greater than. That allows me to say that it's going up. I also notice that it is not equal to, so that means I'm going to use a dashed line when I mark my points. So I'll come back to that in a moment. So now that it's dashed, okay, I come back to my last step here, which is going to be get some points. So again, I'm a fan of the table, but if you want to use rise over run, you go right ahead. So in this case, it was going to be x and y. So my points, again, if you're a fan like me of doing it this way, your points are easy enough. This is your first coordinate, which is 0, 5. So I'm just recording it in the table so to have some points to plot. So 0, 5, because I like plotting points. It's comfortable for me. And the next thing I'm going to do is I'm going to take the 4 from the denominator. That's my next x coordinate, so 4. And the very last step then is going to be to combine the numerator. So now notice there's a negative out here. I always associate the negative with the numerator. So that's going to be a negative 3 and a positive 5. Negative 3 and positive 5 is 2. So I have my 2 points to plot. So when I plot them, I'm going to go back to this. Remember, they are open. I'm not going to make the same mistake that I made before. I'm going to learn from that. So I'm going to go ahead and plot that point, 0, 5. So 0, 5, open circle. Then I go to 4, 2, and I plot that point with an open circle. And then I connect them with a dashed line. So dash it up. All right. Dashed line, there it is. There are some arrowheads on the end. And the last thing I'm going to come to is my whether I shade up or down. That is my last piece right here, which is up. So I'm going to go to my line. I'm just going to put some up arrows on it. And why I like the up arrows is because now I know I'm shading everywhere up here. Okay, so anywhere above this line, then I'm going to shade. So that's a little bit harder of a one, but yet we have one more that can be a little bit harder, and here it is. This is the last one, the hardest of them all. And it may not look hard, but there is extra stuff in this one. So we're going to go to our side work. So here it is, side work. And we write the equation because I noticed that it's not in y equals. So I write 5x minus y is greater than 7. And I'm going to solve this for y. So I'm going to use my properties of equality. So minus 5x. Minus 5x, so that goes bye-bye. And now a common mistake that is made that we want to avoid is we want to carry our signs down, so negative y is greater than negative 5x plus 7. The last step from here is I don't want it to be negative 1y, I want it to be positive 1y. So the way we do that, okay, is we divide by itself. So a negative divided by itself, so if you need a number to go with it, you always put a negative 1. So negative 1, negative 1. Now, here's a very, very important piece. If I'm dividing by a negative or multiplying by a negative, however you choose to isolate the y, if I'm solving for a variable, and we're at this very, very last step here, and that variable is negative, we need to switch the inequality. And what I mean by that is if it is once greater, we then make it less than. So that this is going to become y is less than. And now we simplify the other side. So negative 5 divided by negative 1 is 5x. And 7 divided by negative 1 is negative 7. So now I'm there. So now I go to my next step. My next step is the side up, down, solid or not. So I notice this says y is less than. So that means it's down. And it also indicates that it's not equal to. So it's a dashed line, okay, with open circles. So my last step from here is to get some points. So x, y. Let me back that up there. So x, y. My first coordinate is always the y-intercept, which is 0, negative 7. So the thing you should notice in my tables is always the first coordinate is 0, then the y-intercept of b is negative 7. Now, from here it could be a little bit tricky, but my next coordinate is the denominator of the slope, and in this case it is 5 over 1. If there is no number there, you always put a 1, so it's 5 over 1. All right. Then from here to get to the next point, it will be the numerator, okay, of my slope. All right. And the numerator of my slope is 5. So I'm going to take 5 and -7, and that makes -2. So 5 minus 7 is -2. Now I have my 2 points to plot. So 0, -7. So plotting that point, again, I go back to my notes before, just make sure, okay, that it's open circle dash line. So I'm going to start there. So open circle dash line, here we go. So 0, -7, plot that point, open circle, 1, -2. So I get a 1 down to -2. Got my dash points, and I'm going to dash them up. So here we go. There it is, dashed. All right. Now, this line is almost vertical. But, however, we're going to come back to, okay, this here where I shade. So I go to the line and I start drawing wherever it is, down arrows from it, right? So just to shade that and look at that. So this is where I'll be shading, anywhere below this line. So it looks like it's to the right in this case because the line's almost vertical. But note that it still is down below the y coordinate value. So that is a bunch of different ways on graphing inequalities, so I hope that was helpful.